So first of all, welcome everybody to this live demo today at Polysoude. We are in Nantes at the headquarters of Polysoude with Hervé, who is our weld overlay and welding automation specialist.
Hello everybody, some of you it's the morning or the evening, so I'll just say hello.
We have Emric, who's going to be our welding expert today. He's going to be operating, so most of the time he's going to be behind his welding mask and looking through the mask, through the window, yes. And Pascal, myself, to guide you through the topic today, and Xavier behind the camera. So, first of all, what is Tiger? Let's start with the Tiger. Tiger is a bi-cathode weld overlay process that has been developed by Polysoude. Maybe if we flip around, we can see on the trolley dummy piece that we can that we will emphasize on a little bit later. Just to give you a first glance of it, you see here the two cathodes and the weld, the wire coming in. We're going to come back to that in a few minutes. It's exactly the same topic. I'm going to show you the one that we have prepared to you on the demo set, because once it's going to be live with the arc, it's going to be a bit difficult to see. So today's demo is going to be based on using a Polyclad easy demo version with a small turntable, a workpiece that simulates a flange, about 390 dia. And this morning, in order for it to speed up the process, we've already put the first layer on, and this afternoon we're going to be on the second layer. Hervé, maybe a couple of comments on the finish of the.
Sure, so here on this first layer we started, as we said, on the carbon steel base material. We have used Inconel 625 wire, which is the most common in the industry, and we started from the center and ran towards the OD of the workpiece. We do that to start with a minimum of heat at the beginning, at the middle of the workpiece, and then the more we are outside, the more there are some massive material, and the better it is to keep a constant temperature. So now we will run, when we'll start to strike the arc, in the same way, starting from the center, running towards the outside for the second layer.
Okay. So as you can see, you see the electrode with the bi-cathodes. The torch, the lens that we are using today is a ID 150, which is one of our most common standard lens. Usually in our family, we can start with the Tiger as of 100 millimeter dia, and then we can go up, as 100 millimeter when you're welding inside of a tube. So today we're welding on a flange, so it doesn't matter that much. Of course, behind all that setup, there is the power. So we have our two Tiger generators. We have two cathodes, hence two generators, a master and a slave, that are operating the whole system. It's not only the power generation, but also the brain that controls all the automatic on the system. So I think the presentations are made to start with. So maybe Emric, while you are getting started. For those of you who are not really familiar with Polysoude, just wanted to give you a short introduction of who we are. Here at Polysoude, Polysoude is a company that has been founded in the 1960s, and it's more than 60 years ago that Polysoude has been founded. Started in TIG welding, so we do all about the TIG. And in the 90s, we have developed a cladding application that we've called the Tiger. Polysoude is based in Nantes. but we have a worldwide network of over 50 technicians and welding experts that are gathered around the world, that are traveling around the world in order to assist our customers in all their welding applications. So as you can see behind me, Emmerich has started the application in the middle of the workpiece. Maybe I can just have you get to have a look. Getting a bit closer. So I hope that you have all your masks on. So here we are starting at the center of the workpiece and going slowly towards the outside. So the Tiger technology, Hervé, here we are working on a flange, but what are the other applications that can be used?
A very common application is the internal cladding of pipes, short pipes up to 12-meter pipes for oil and gas industry. We have done as well up to 18 meters for risers. So ID cladding is one of the most favorite applications. As you said, Pascal, the flanges with or without ring grooves are a common application as well. And we start to use more on tube sheets, means like a big flange. For the nuclear industry, and as well for thermic pipes, some OD cladding, could be OD cladding, as I said, about thermal pipes for boilers, but we have as well sometimes some applications for external cladding for shafts for big cylinders, which is less common.
Mm-hmm. But in the industry, the typical application in weld overlay is using TIG hot wire. So one may ask, why Tiger? Why using two cathodes and not sticking to the regular TIG hot wire?
So TIG hot wire, which is used as the main process when we need a high quality, is doing well, except it's quite slow. With the Tiger technology, we can achieve the same quality, even a little bit better, but we multiply by 2 to 3 the welding speed.
So in TIG hot wire, what is the typical linear speed that is used?
Let's say usually we can be between 400 and maximum 600 millimeters per minute.
Okay.
When it's optimized, whereas with the Tiger we can run very smoothly 800 millimeters per minute when we have difficult conditions, and in the best cases up to 2 meters per minute. Most of the production machines are running around 1.2, 1.5 meters per minute.
Okay. So there is a huge gain in productivity for the customers.
Yes, as I said, multiply by 2 to 3, keeping the same quality.
Okay. Most of the time, are the customers machining the cladding, or are they just leaving it as is?
Depending on the applications. If we speak about 12-meter pipes ID cladding, the surface is only sandblasted and there is no remachining afterwards. When we are speaking about smaller workpieces like flanges or termination hubs, then it's machined. This question is important because the better is the quality of the surface when we start the cladding, the higher can be the cladding speed. For a sandblasted surface, 1.2 meters per minute is common, but it's already not challenging, but not so easy. 1.2 on a machined surface is very easy, and on machined surface we can run 1.5, 2 meters per minute quite easily.
Okay.
The Tiger can be used in a flat position, as demonstrated today, flat or ID in 1G position. It can be used as well in 2G position, workpiece being most of the time vertical then, with the same speed, nearly the same speed.
So That means for a flange, you have a continuous section, but are there any limitation when you have a valve or when you have a bore, for example? Is there a limitation to use a Tiger?
If we have some crossbore, some intersections, it's not the Tiger itself, it's not the welding technology which has to be upgraded, it's more the management of the trajectory. Then instead of this simple demo machine, we can use CNC control to manage most easily the programming of the complex trajectories. But the Tiger itself is not limited to flat surface, not limited to circular trajectories.
Okay, so the CNC just makes it easier for the operator to use the Tiger. Okay.
And for the programmation.
And the programmation. Okay.
So I don't know where we are exactly in the revolutions here, but we can hear that the speed of the turntable increased a little bit. Of course, in the center we cannot run full speed because we are playing with the limit of the process to keep a regular surface, a good thickness, and a good dilution. And for the center we are around 700 or 800 millimeters per minute. But you will see after a few minutes, after this center part is clad, we will increase the speed to 1.2, 1.5. We'll check together how much we are today. So as you can see, even through the mask, it's perhaps not easy at distance with the video, but you can see the arc is very smooth. The process is very stable. There is no difficulty to run this machine even at high speed, and there is no bad surprise or complexity for the operator running the machine. Now we had a ramp of speed to increase the cladding speed. How much are we now, Emmerich?
1500.
Okay, 1.5 meters per minute, so it's the, let's say, the common travel speed once we make the center. And this travel speed will be kept till the OD. It will take just 15-20 minutes. On the machine, even without CNC, when we are cladding on flange like this, after each step over we are on a new diameter. But in the program we just indicate the welding speed that we want to have, and the machine calculates the rotation speed of the table to be always at the programmed travel speed.
So basically the machine calculates the heat input, the energy input in your workpiece, because of course all of you may know that in cladding the trick is not the finish of the layer, but it's the ferrite content in your second layer that is the most important. So usually you're looking at a ferrite content in the oil and gas industry who is below the 5%, am I right?
Yes, for sure. This is the expectations, below 5 with 2 layers. Usually we are around 2 to 3% when we are running at high speed.
Demande la vitesse du wire spool.
On
peut pas l'avoir. On peut pas l'avoir, mais c'est
800 we had a question through the chat, some question about the wire speed. We are using Inconel 625 1.2 millimeter diameter, and we are running 8 meters per minute of wire. 8 meters per minute of Inconel 1.2 gives around 4.5 kilos per hour deposit. There is no use to have a high deposit rate. The important thing is to achieve as fast as possible, I mean travel speed, the expected thickness of the layer. So here, linked to this question, we have only one wire, because at Polysoude we prefer really to use only one wire fixed with a strong bracket to ensure a good position of the wire in the weld pool, and this is what gives us the possibility to run at high speed. It's as well really easier for the operator to adjust in a perfect way only one wire than two, especially when we are in small IDs. Two wires are taking more space, and finally after the test we made no improvement of deposit rate, but more difficulties to keep a smooth process running without any stop.
So while Emmerich is resuming the cladding on that workpiece, we just go over to the workbench, and we can show you a couple of samples that have been cladded using our TIG technology. So it's like Hervé mentioned it. It's not only limited to flat surfaces, so we can weld in 1G or in 2G. We can weld on flanges, but also one of the preferred applications is the inside of pipes. So we start from 100 mm, and we can go up to 72 inches pipe cladding. We can do also cladding on the outside of the tube, and so here you can see some of the test pieces that have been done all using a carbon steel base and an Inconel 625 layer, 2 layers on top actually. So here you can see the smooth finish, and using the cladding, there is always a question about the binding of the cladding. So using our technology, by mastering the heat input in the system, we are able to guarantee that there is zero defect binding of the Inconel on the stainless steel. So when we are in progress on our equipments, what changes is not that much the technology, it's mainly the carrier of the lens and the torch. When you are using flanges or valves or BPOs and so on, then you use a column and boom type of equipment. You can also use the lenses, the Tiger lenses, on 12-meter cladding rigs or 18-meter cladding rigs that are more conventional on a cable system, where you can have 2 torches welding or cladding one behind the other to achieve a better quality.
What is the thickness of each layer?
So the thickness of each layer, usually you aim for about 3 mm, 3.5 mm per layer, and you can see here on this sample, you can clearly see the first layer and the second layer on top of it.
As we are still on the TIG process, the tire is based on the TIG process, so we are still able to adjust all the parameters separately, which gives the opportunity to adjust the layer as we want. Most of time in oil and gas, the total thickness which is asked is around 3.2, 3.5, and in this case we minimize the first layer to 1.5, 1.8, and we make around 2 millimeters with the second layer.
So here all the applications that you can see are circular, but of course in the pipe industry, when you have to rebuild the seam of a pipe, it's possible also to have an application using what we call the cladding L system, longitudinal, where we rebuild the inside layer of a cladding inside of a pipe on a longitudinal way.
And this is done with twin Tiger solutions as well.
Yeah. So, just a couple of words on how we came up with the idea of using 2 cathodes, or why is it working. Basically, it's like all the big inventions. It started by we were looking for something else. We were looking for a high-speed welding process, and we say, okay, put twice the electrodes, you put twice the energy, so you can get twice the speed. Unfortunately, that doesn't work like this. we found out by experimenting that there is some magnetic effects that reduce the arc pressure. And of course, when you weld, you are looking for arc pressure to get a good penetration. In our case, using the two electrodes, we didn't have that arc pressure. And somebody said, oh, but if the heat is not pushing on the inside, this is perfect for the cladding, because you want to be as cold as possible in order to avoid and to limit the dilution of your ferrite in your inconel. And that's how all the story has started, by using two cathodes for the Tiger application. So apart from using the two cathodes, we have pushed the boundaries out by inserting on our lenses and on our equipment HD cameras that are able to actually give you a 100% record of your pipe. Obviously, imagine you are welding on the inside of a pipe. You are in the middle, 6 meters in, and your wire runs out, so you have to restart again. Of course, without the camera, there's no chance for you to start and to find the right spot. So not only our system is able to remember where it was in the pipe and where you stopped, so you can restart and at the same position, but also you have a visual control and a visual record. So the cameras help you to get back to your position, but also to ensure a quality control. The newest application that we have, because on one side you have the camera, on the other side you have all the measurements that are done in the data acquisition that is done during the process, where you acquire not only your welding parameters, but also it computes the heat input and compared with the wire speed. And we were able to bring both together, so that when you spool in your data acquisition back to a certain position because something went off, you are able to find the video, and you are able to see actually what happened during that sequence in order to detect a possible defect that you would have to correct. So today, the quality control is one of the big question, or the big task that our customers have to resolve. And today, the certifications are very strict. So today, the Tiger technology is based on TIG, has been approved by, we have API certifications, we have Saudi Aramco certifications. We have been certified by ADNOC in the UAE. So all the big countries in the oil industry already use in production 24-hour 360 are using our Tiger equipment, and it's running around the clock. Maybe we can go back to see the progress. So we had almost two-thirds of the workpiece.
So as you see, it's going quite fast. Questions that we have in live is which kind of parameters we are using, running at 1.5 meters per minute travel. I think current is around 200 amps per electrode.
Yes. Just 195 here.
195 current per electrode. You can see there is a little bit of pulse. And the wire, how much do you have, Emeric?
8 meters.
And the current?
Hot wire current, about 70.
70 amps on the wire only.
So here we are in perfect conditions, being based in Europe and in the spring, but the systems that we have already operating are based all around the world. We have some equipment in Russia where the temperature can go down in winter, but also equipment in Saudi where you are around the 35 to 40 degrees with a huge humidity around, and all the cooling systems that you may hear in the background are dimensioned to face these critical conditions.
One question just coming from the US related to the real-time data acquisition. So we did not connect any DAC box on this demo machine, but it's a standard option and even delivered on the production machines. We have to process on the power source an extra measurement card, which is taking all the real parameters, and then we display and we record these parameters directly on the hard disk of the laptop or the industrial computer. We can display all the parameters independently, the current of each electrode, the voltage, the current on the wire, the travel speed, and we have up to 16 channels that we can customize depending on customer wishes. So sometimes it can be a preheating measurement. If we have some massive gas on the power source, we can record and display as well the flow of gas. So the different possibilities, most of them being of course the pure welding parameters, and the machine, the data acquisition, calculates automatically the heat input, and you can display as well the deposit rate from the instantaneous deposit rate, and as well how many kilos you deposited from the beginning of the day to measure your productivity.
So about the type of equipment, I mentioned that we have a whole range of torch carrier. The one that we are displaying today is the smallest of the family. Of course, the different column and booms can vary in size depending on the workpiece that you have to do, but the principle remains the same. As soon as we have confirmation about the type of workpieces that our customers are looking at, we help them to select the appropriate tool for them to conduct their operations. Once the equipment is ready, it's getting dispatched to site, and one of our installation team assists for the commissioning. So it's not only our welding expert, but it's also our mechanical and electrical engineers. So we can of course adapt to all kind of power supplies, whether it's 50 or 60 hertz, 110 or 403 or 380 volts. In our range, we have also what we call our compact cell, where basically it's a mobile cladding rig that fits inside of a container that can be shipped or shifted from one workshop to another, so that you can be operating as close as possible to your customers if required. So we are getting closer and closer to the OD of today's workpiece. So you can appreciate the quality of the surface, and what you can see also is the thickness of the layer. So the 3.5 rough that I mentioned. And also while the workpiece is turning, one of the tricky parts is always to get a good cladding on the outside. So the last run on the outside of the workpiece is usually quite tricky, because you are at the edge of the workpiece. So your heat dispersion or heat pumping is slightly different. So it's quite a tricky layer to be done. But you can see that for the Tiger, it's absolutely not an issue. You have a perfect run on the outside, on the edge of your workpiece. So apparently we are back online. We just had our camera who had some issues with the heat and didn't like it too much. So we are back online. But we try to stay a little bit away till Emmerich has done the final run. Avi has taken over the camera. So today at Polysoude we have over 15 welding experts who are able to run around the world to assist our customers to develop the parameters. Of course, the machine wouldn't be anything without using proper training for the operators. So we are used to train the operators in most parts of the world. In German language, in English, it's absolutely not a problem, and we are able to provide also the perfect support to be there and ensure a service remotely to assist if there is any deviation. One important fact that I would like to mention at this stage is one question could be, what about the operating costs? Because it's all nice to say, okay, you are fast, but if the consumables cost you a fortune, what's the point? Based on the experience that we have and the feedback of our customers, we estimate the costs of the running cost and the operation costs of the equipment at about €6 per hour.
Don't stay too close, it will be hot again.
It's hot. So I think now that the arc is gone, you can appreciate the quality of the surface that you are getting. So
just wait a little bit that it's cooling down before we come back with the telephone close by to the workpiece. But then we can show you the quality of the surface, and we can show as well the design of the torch and how easy it is to adjust the electrodes, which are just standard lanthanum electrodes, 4 millimeters with classic 30-degree grinding.
So again, the Tiger is nothing else than a TIG process. It's just a variation of the TIG. So the electrodes and the consumables, it all is very similar to TIG hot wire. Because in this case, we are using the hot wire to get to that speed. But it's not a new or revolution welding process. It's something that is well known in the industry, that is accepted by the industry and already used in most of the countries where cladding is operated. Emmerich is just opening the head of our torch.
You can see that Emmerich is directly touching the electrodes because we have a strong water cooling of the torch. This is part of the, let's say, not the secret, but the efficiency of the torch, a good water cooling, which gives the possibility to run 8 hours without stopping, not changing any electrode or wire tip. This is quite common, one complete shift without any stop, if you have a spool of wire big enough, of course. And the electrodes, you see, can be directly disconnected from the top. For the adjustments, the angle between the two electrodes is fixed, so you just have to adjust the stick out compared to the nozzle.
So we can tie it from here, the two electrodes. And we must have 1.2 millimeter between the two tungstens.
Lucky that the wire is 1.2. That's a good gauge.
And then the setting between the tungstens and the wire is 3 millimeters. So we use an Allen key.
Very good to have a good Allen key.
And let's go. See, it's just touching, but it goes smooth. Okay.
So the setup is one of the keys, because at the end of the day, it's more efficient to waste or to lose 10 minutes or 15 minutes in the setup of your torch, of your electrodes and your wire, because once you are inside of a pipe or on a job, by the time you get it out, you have to fix the problem that might have occurred because of a faulty setup. You will waste more time to resolve the problem. So in all these operations, we are looking at having a good deposit. That's just a reminder. It's the ferrite content that matters. It's the thickness of the layer that is important, and the quality of the finish of your surface. And all these three factors combined with the high speed, that is what provides, gives the benefits to our customer of the tire. Because at the end of the day, our customer have to make it work and financially for it to be viable.
Just to show the flatness, I will not let it too long because it's still very warm, but as you can see, the flatness is quite regular, constant. We have very reduced, I call that waves, my English is perhaps not so good, between each step over, which means you do not put more expensive material than needed really for the application. So for the customer who have to remachine after the cladding, first you put less expensive material for nothing because of this very good flatness, and as well you have less to remove by machining afterwards.
So
some question for interface.
Yeah, we have a couple of questions coming through the chat room. So about the interface and the programmation. So Emric?
This is the programmation.
So just have a quick look. So the setup can come in all kind of in all languages that you wish. So the setup is, we call it PO Win. So it's a programmation that is inside the brain, is inside of our generators.
Okay. So here, this is what you can see during the welding. So the speed of the wire, the speed of the rotation, the current, tension, and here you have all the programs. So it's line by line. You can find the current. So here, if we go down, okay, we can see the current here is 200 amps and the base current is 180 amps.
Okay.
The pulse is 50 milliseconds for the high current and 100 milliseconds for the base current.
Okay. So on the flange, like the one that we just showed, how many sectors how many different type of programs have you used? 3, 4?
So I used 3 sectors. One for the very beginning because it's a really small speed. Then I use an intermediate speed, and then the full speed. So there is a function that calculates automatically the new diameter at each step. So it's pretty easy to make the program.
So these sectors are linked to the center of the flange. It's
Yes.
not necessary where you are
Sometimes-
cladding inside a pipe or whatever, then you have constant parameters.
So this is the remote control. So from here I can adjust every parameter. So this is the start and the stop button, the restart button, downslope, and then here I can manage with the current. I can manage with the tension. I can also adjust the hot wire. And well, if I need to, I can also move during the welding. And I can also adjust the speed of the wire here. So I can cut the hot wire cut the wire, adjust the speed. I can choose to adapt only the high current, base current, or both. And we also have a simulation.
So again, a basic remote control that allows you to override the program, the parameters, and to adjust them during the welding operations,
exactly,
depending on the situations, yes, that you are facing.
And I can see afterwards all the parameters that changed in the programmation.
The program that you have seen on the laptop is used to be introduced in the power source. Here we let it on the power source to show the parameters and the way it's built, but you don't need to keep the laptop connected to the power source during the operation. It has to be there just to inject the program in the power source, and then the pendant is sufficient to run the machine. For the people interested in quality and limiting the freedom of the operators, this is an important thing as well. In the program, you can advise how much, what we call deltas, you can allow to the operator. For current, for voltage, you can describe what are the limits. Each time you press the plus or the minus button, it will trigger a small delta, and you can limit the number of delta. So if you limit 10 times 1 ampere plus or minus, then the operator can press as much as he wants, it will stop. So this is important as well for the records of the quality, if you want to be sure to be close to the WPS.
Okay.
The workpiece is quite warm, so we have a question to measure the ferrite content. So we cannot use the PMI gun on this hot part, but we have one which has been made this morning or yesterday, I don't know, which is just over there. Yeah,
it's our test piece, where you can see multiple stop and starts and layers. So if we go on the outside where we have our 375.
This one is 2 layers.
So in the second layer, so that's what we have on the outside. We're at 375. So below the 5% that you are looking at. Perfect. Thank you. Okay. We can just see there are no more questions currently in the live, but if afterwards that demo is going to be posted on Facebook, is going to be on YouTube as well, please don't hesitate to share it around you. If you have any questions, you can contact us. You can contact us, Hervé, myself, via our website, www.polysoude.com, and the contact form. So don't hesitate if you have any questions on the system, on the performance. We will be ready and happy to assist. I would like also to use that opportunity to just to inform you that we are opening operations in the US. So our colleague Eric is going to be based. He is based in Houston, and will have demo capability as of this summer in Houston. So you can also contact him. We will forward all the information, but you will be able to get in touch with him as well, and to appreciate that a live demo in the US by the end of the coming summer. So thank you very much for joining us today. We had Emeric, Hervé, Pascal, myself, and Xavier on the technique. Thank you very much for today's view, and see you next time. Take care. Bye.